should go into this a little bit more and talk a little bit more about files so you actually have enough information to go through on your homework number 4. Now, I do have a secret message for you, a secret encoded message. During today's presentation, we will cover a topic that is critical to you. Because in homework number 4, what you're going to discover is all that beautiful, wonderful patient record data that you used to be able to just look into the list of lists and get is no longer there. Instead, it has now been placed
in a text file.
Into a file. Which means you have to read it out of the file and effectively build your lists. Okay. I mean, you get to Python. You feel comfortable with that. You can step through strings and figure out where stuff is, delimited and pick out last names and first names and middle initials and stuff like that. And you can do that. In fact, when I gave the assignment to my TA, that's exactly what she did. She wrote a chunk of code. Legit code that reached in and pulled out and did all that sort of stuff like that. But it turns out you can do it that way, or I'll give you one magical Python statement that will do it for you at some point in time during my discussion today. Will that save you a ton of time? I'm just saying. Feel free to do what you want. But I tell you, there is magic in this presentation today. All right. So let's see, reading lines from a file. Now, last time we talked about reading lines from a file, what we used like a read line or something like that, right? And went into a file and grabbed a line. So let us just review ever so briefly what the heck is a line. It starts on the left-hand side, and it goes to the what? So \n is the secret message that tells you I have hit the end of the line. \n is the secret code for go to the next line, right? So basically what's going to happen is you're going to read all the way until you find the \n, you're going to say end of line, and poof, that's what gets shipped back to you, right? Okay? So we figured out how to do that, but there's actually a simpler way. So instead of using that, line input or whatever the heck it was, what we can do is we come down and say for line in, and then this is the variable that's associated with the file, print line. So basically all we need is a for loop, and we can just reach in and grab out each individual line in that particular file. We can do this because Python can treat an input file as though it was a container of strings. Container is the magic word to say basically you're treating it like a list, a big honking list, in which each line comprises an individual string. So you just basically loop through it. However, there is one critically important difference between treating a file like a list and actually having a list. The big difference is the fact that you start at the beginning and you go through it. Maybe I put the next one here. One key difference. Bam. Once you've read a file in, you can't go back. Right? So I read in the first line of text. Excellent. I go to the next line of text. Great. Oh wait, there's something I wanted off the first line of text. Sorry, you're out of luck. You can only progress through a file when you're reading it in. You go from top, you go to bottom, poof, you're good to go. Now you can play games, because you could close the file, and then you could reopen it, and guess what? You're back up at the top. Got it? Got it? Now, let's remember here for a brief moment that the print function prints its argument to the terminal and then starts a new line by printing a new line character. Right? So every time you print something, where does it end up? Start of the next line, right? Okay. Hello world, poof, then I'm at the next one. Okay? Because each line ends with a new line character, the second new line character is going to create a blank line in the output. So remember, when we suck in a line off a file, it has at the end of it, it has a \n, which basically says go to the next line. And when we do a print, print is automatically going to. So if we put these two together, what are we going to get? A bunch of blank lines showing up, right? Generally, new line character must be removed before the input string is used. So this would be the most excellent time to take a look at this. It looks like we have the code that will make this. Try this at home ever so much. Here's some incredibly sophisticated Python code. I'll probably have to go through it so that you can understand what we're talking about. So these are comments. Yay. In file equals open, double quote, name of file name, which is homework number 1. And we opened it using an R, which tells us what? Read. Right, so we're not going to write to it. For line in file is right here. So line in file, print line. In file dot close. That's it. So what's this going to do? So for now, homework number 1. Looks like it, right? Pop open your homework number 1, read a line out of it, print it, grab another line, go, 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 go until you're done.
Hopefully you double space.
Double space, do you think? Let's find out. Woohoo! Does it look like there's a lot of blank lines in there? And why are those blank lines showing up? It's because print always goes to the next line, and because we're sucking in those lines, and at the end of each one of the lines that we suck in from the file, there is a go to next line command, right? So collectively, poof, it takes us all the way down there. Well, that's rather, shall we say, annoying. Okay, so what can we do about that? How can we get rid of this extra go to next line? So when we bring it out line from the file has the word spam on it. When we suck it in, it's going to be spam _n. That's what we'll actually get in our program. Okay, cool. If we want to get rid of that \n, we've got a magical command called rstrip. Pren. Okay? What this is going to do is it's going to strip off pretty much everything at the end that's actually not part of our string. In this particular case, it's going to get rid of the \n. By default, so in other words, if you don't specify anything, rstrip method creates a new string in which all the white space. Now remember, white space is made up of blanks, tabs, and our old buddy Mr. Newline at the end of the string are removed. Okay? So for example, if we've got eggs, blank space, \n, and we did an rstrip on this, we would end up with just eggs. So we do that, so we've got our little homework number 1 problem here. I wonder if we can do a better job of this. So what do we have here? It's pretty much exactly the same thing that we had last time. So in file opens homework number 1 for reading. That's fantastic. For line in file, print up. Here we go. Line dot rstrip print, and then we close it. So what's going to happen this time? I mean, the only thing we did was add this little rstrip thing, right? What should we see this time when we run the program?
No more new lines.
Which means what will it look like?
It should look like the actual file.
So should we, like, you just put it on the screen and listed it? Okay. Whoosh! All right. Does that look like you're like editing it or just listed or something like that? So this is pretty much exactly the same thing you just saw. The only difference is that we don't have that extra blank line in there. The reason we don't have that extra blank line is because we stripped out the blank line, right?
Like I said, strip out blank characters as well.
Yes, but wait a minute. The trick on that one is you're exactly correct. But where does it actually do the stripping? At the very end. So spaces, tabs, or new line from the tail end. Okay. Now, rstrip actually has some secrets up its sleeve, so we'll get to those ones in a bit. So reading words, okay, reading words. Sometimes you might want to read individual words from a text file. So I have a text file. It's got words in it. Words are collections of what? And how do I know what a word is? How can I tell, pick a word out of a file? Is there like a big flashing arrow that says this is a word?
Well, the good probably was spacing.
Spacing, what do you like double spacing, triple spacing?
The space character.
Space character where?
Between words.
Between words. Just between words?
Also between the characters.
Well, if it's different characters, suddenly we're no longer a word, right?
But
So if I was going to define what a word was, what does a word start with?
a character.
Yes, but what comes before that character? There you go, right? Then I've got a collection of one or more characters, right? And then what comes after the word? A space. So we have sort of a bunch of characters sitting on a little pillow in between two spaces, right? Or the beginning of a line, right? Or a \n, right? So either one of those could be the start or the end. So we have sort of like three scenarios thinking, right? Okay, because there's no method for reading a word from a file, you must read a line and then split it into individual words. So this can be done using the split method. Line.split, paren. Okay? Split method returns a list of substrings and results from splitting the string at each blank space. So does this seem like this would be a powerful tool? Would this be a hint from your professor to you? So you could read in a line from a file, and then you can just do this little split thing on it, and poof, it gets up. So let's see what this actually does. So, here we go. So you've seen all this before. Comments? In file, opening, oh hey, the US Constitution. Cool. How does the US Constitution start? Excellent, very good. That's right. That's about all we all know. And we're going to open it for what? Which means what? Read. So line equals infile.readLine. What's this going to do?
Read the first line.
And it's going to place it in? Excellent. Word list equals line.split paren. What's that going to do? Yes, and it's going to put it where? And what would be the very first word in word list? Read. Not the French. Okay, good. All right. Then we're going to print word list. So what would we expect to show up here? A list of all the words that are on the first line of the US Constitution, right? Cool. Now, two blank lines for word in word list, print word. So what's this going to do?
It's going to print all the words in the list.
Right, so each one word per line, right? Basically just kick it out. And then we do, of course, the incredibly important infile.close. Bam, we're good to go. All right, let's see what this does. Woo! Wait, stop, and close. So here we go. So we printed out all the words. So we sucked in the line, first line of the US Constitution. Thank you. And when we did that split thing, right? Look, we turned it into a list, didn't we? Oh, that could be handy for our work this thing. Saying, we the people of the United States in order to form a more perfect union, blah, 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 bam. And then what we did is we stepped through and we printed out each one of those words, right? We the people of the United States. So basically what we found is a way to bring in input from a file. If we know that it's actually broken up into words, we can use a simple one Python command, and bam, we break it up into each individual word. And then we can do anything we want with those words that we want to, right? All right, this is good stuff. It seems like a powerful tool. Trimming strings. Okay, so sometimes you gotta bring in a string and it's got too much stuff in it. I don't want all this stuff. So blank spaces are not part of substrings. They only actually set delimiters for where the string is split. And notice that the last word line contains a comma. If we want to print out the words contained in the file without a punctuation mark, and we can skip those from the substring. Here, so we had our little R strip thing, right? We did R strip paren, and what it did is it trimmed stuff off the end of the line. Turns out R strip does a lot more than that. If we pass R strip some characters, period, comma, question mark, exclamation mark, what it'll do is it'll go through the whole string and it will get rid of those characters. Just get them out of there, okay? So R strip's a very powerful tool that we have here, that we can actually trim strings down and only make sure they only contain the stuff that we want them to contain. Okay, by default, the split method also uses the white space of characters as the delimiter. So remember, when we brought in the first line of the Constitution, we split up that first line into individual words, and the way we knew that the words were separated was because we knew there were blank spaces in them, right? But there is this thing called a CSV file. What is that? Right. And how is the data in that one separated? Commas. Comma separated value, CSV. So you can do it 1,000 different ways. You can use colons, you can use other sorts of stuff like that. Very, very common out in the world is to use commas to separate stuff. This example uses a colon, but if I did line split colon, what I'd be telling line split is, hey, all the words in that file are separated by a colon. Go ahead and give me all the individual words that are separated by a colon. If I change this to a comma, then I could read it, for example, like an Excel CSV file, and I would be pulling in off each individual word. This could actually be very important. Cool. All right. So you can also read characters. Hot diggity, man, you can read just about anything you want. Instead of reading the entire line, you can read individual characters with the read method. So read method takes a single argument that specifies the number of characters to read. Method returns a string containing the characters. Here we go. So character equals input file, whatever that happens to be, dot read, and I got a 1, which means how many characters am I going to read in? Just one single character. The read method returns the string consisting of the next character in the file, or if at the end of the file it was read, then it returns the empty string, blank blank. Okay, well cool. So now we have the Python power to read in individual characters. So, you know what we probably should do? We should probably go back to the US Constitution and let's count how many occurrences of each letter there is going to be in the US Constitution. So my question to you is, what do you think is going to be the most popular letter in the US Constitution? Okay, what's number 2? You think T? You don't think another vowel?
Wait, what?
I guess.
Oh, maybe O.
Then O, then A. Wait, is C even?
All right. Why would there be a Z in the Constitution? All right. So here's what our incredibly sophisticated Python code, probably never seen before by human eyes, is going to process the U.S. Constitution and count the frequency of each letter. So we start up here. We've got some comments. Letter counts equals bracket 0 bracket times 26. What's going on there?
Basically the 26 slot string.
String, or what's a better way to call it? List. It's a list, and it's got 26 what's in it? Zeros. List with 26 zeros. Incredibly unuseful, but what do you think we're going to use that for? 26 is a magic number. So maybe it's going to be a count for each letter in the alphabet. Cool. All right, so here we go. In file equals open the U.S. Constitution, and we're opening it R, which means we're opening it for what? Excellent. Fantastic. Character equals in file read 1. What's this going to do?
Read on the first character.
Read first character. In the U.S. Constitution, the very first letter is?
W.
Is it an upper or lower? Okay. Fabulous. Okay, while character is not equal to quote, quote. What's going on there, one?
That's just making sure you don't end up hitting that.
End of file, that is exactly correct. So character equals character dot upper, paren, what's that do?
Uppercase, and but automatically puts uppercase.
Cool, so now I don't have to worry about lowercase or uppercase. Everything's uppercase, right? Fantastic, here we go. If character is greater than or equal to A and character is less than or equal to Z. What? Why? What? Why are we doing that?
Making sure it's ASCII.
And ask you what?
Like a period or something that's actually a letter.
Ha! So you said two things in the same sentence. That's really super cool. Making sure that it's a letter and it's not a
Character or anything else.
number, exclamation mark, right. So we only care about the letters of the alphabet, right? So assuming we just sucked in a letter, code equals ord char minus ord A. What kind of Greek is that? What's going on?
Well, that turns whatever the
Character. The one character we read in
turns it back into an ASCII value.
into an ASCII value, and then what do we do with that crazy ASCII value?
Subtract
Subtract whatever the ASCII value of capital A is from that. Great, so let's say we sucked in an A. Poof! So we'll turn it into whatever the ASCII value for a capital A is, which happens to be 65. Then what are we going to do? Subtract from it.
65.
And we're going to get the value of what?
0.
Ah, okay. If we bring in a Z, we're going to get what?
91.
Okay.
No.
Close.
How many letters are there in the alphabet?
26.
And we just figured out A is what?
Oh.
So we would say Z would be 25. You with me on that? You don't want, you know, we don't want to move on until we're all comfortable with this. You gonna be good with that?
Yeah.
Okay, so basically we're gonna come up with a number between 0 and 25, which is 26, right? And you know, because we want to figure out which one of these little buggers up in the list we should increment, right? So great, we've done all this. Letter counts, bracket, bracket, code, which was the secret, what we just calculated, equals letter counts code plus 1. So we found a letter, we're going to increment in the list the position associated with that letter, and we're good to go. And then we do char equals in while read 1, which basically gets the next letter, and we do the whole while loop over. Bam! We do all that, eventually we hit the end of the file, right? Woohoo! That's the time to figure out what's going on. Current character equals 0. Okay. For pointer in letter counts. Oh, that's the list that we put together. Print character, current char plus ord A. Oh my god, how complicated is it? So let's see, current character right off the bat is going to be 0. So I'm going to take ord A, I'll take A, turn it into ASCII, and I'll add 0 to it. And then I'm going to turn it back into a character, and I will have A, right? So I'm going to print out an A, and then I'm going to print out pointer, because pointer is in letter count, so I'm going to pull out each item in that list. I'll print it out there. And then current character equals current character plus 1, and then it goes through that for loop, and then I end up closing the file. Oh, jeez, really? All right, so based on this code, it looks like what I'm going to do is I'm going to pop open the U.S. Constitution. I'm going to suck in a single character. I'm going to make sure that it's an alphabetic character, A through Z. Then what I'm going to do is I've got this little list of 26 items. I'm going to figure out where in that list this letter is being kept track of. I'll find that spot, I'll increment it by 1, and then I'll keep reading in characters until I'm done. When I'm all done, what I'm going to do is I'm going to print out the letter in the alphabet, A, B, C, D, E, F, G, and then right next to it, I'm going to print out the count for that particular letter. Are you ready, potentially for the first time ever, to see the frequency of letters in the U.S. Constitution? Sure. Is this going to be like one of those, like, what is it? National treasure movie type of thing, where you find like a secret.
Yes. 600
letters of the Constitution.
Ta-da! So what is the most popular letter in the U.S. Constitution?
Z. T.
Oh. It's like it's E by like a big margin. So what's number 2? What's number 2?
T.
How about number 3?
A. Is A.
Is it A? I think it is A.
Yeah.
How about 4? Who's after A?
That would be like N and O are both tied.
They are, aren't they? Wow, I wonder if they wrote it that way.
Oh yeah, and S is 100.
That's a little surprising. You would think S would rank a little bit higher than that, right? So anyway, so I was doing this and I took a look at it and I thought, well, that's sort of interesting, but you know what caught my attention? The Z. So how many Z's are there in the U.S. Constitution? So are there any zebras, xylophones, or zigzags, to the best of your knowledge, in the U.S. Constitution?
Whose name has a
It definitely is.
Like it may not start with a Z.
It doesn't have to start, but it could. It could.
Someone has a name.
So this one intrigued me just a little bit. I was like, wow. So I wonder where you use Z in the U.S. Constitution, because it didn't inherently jump out at me. But then I thought to myself, well, I got some mad Python programming skills. And I got this fantastic program that has the ability to process every single letter. How hard could it be to maybe jinx with this program and ask it to actually cough up the words that have the Z in it? It couldn't be that hard, could it? So let's think about this a little bit. So this program runs through and it processes every single letter in the Constitution, right? Okay, great. So it's zipping along and it finds a Z. Now, is it going to find a Z at the beginning, middle, or end of a word? Yes. I think the answer to that question is yes. It will be somewhere in the word, right? Okay, so that is the word. That's the word I want to print out, right? So how am I going to do this? It seems like when I find a Z, I want to go, oh hey, well, but I'm not going to be at the end of the word, am I? So I'm going to want to keep reading in letters until I hit the end of the word, right? How do I know I hit the end of the word? Space, right? Okay, so I want to keep reading words until I hit the end of the word, the space. Now, how do I know when that word started?
Because of space and a character.
Gotcha. All right, so it seems like every time I hit a space, I should start to build a word, right? Read in a character, add it to the word. Read in a character, add it to the word. Read it in a character. If I find a Z in the word, do I want to print it out?
Yeah.
Cool. If I don't find a Z in the word, what do I want to do? Throw it away, right? All right, so this seems like it's pretty straightforward Python code. Let's see if we can figure out. Let's take a look at it and see if we agree on this.
If that shows up, Jeremy, I will give you $20.
If what shows up.
Everyone wants to come.
It's all about the Z's, I tell you. Don't show them the Z's. Oh, well, we'll go ahead. All right, we got some comments. In file says open up the U.S. Constitution for reading. Fantastic. So this is all the same sort of character. Listen, current word is a null string. Is a Z word. It would have been cool if I made a Boolean, but I wasn't that smart, so I just made it a 0. Okay. Well, character is not equal to the end of the file. We've seen this. Character comes in, we make it upper. If character is actually a letter between A and Z, hey, is character equal to Z? If it is, we found a Z word, right? Set my flag is Z word equal to 1. Okay? Current word equals current word plus character. So what we're doing is we're taking the letter we just rounded in and we're sticking it on the end of the word that we're building, right? So we're building the current word. So we keep doing this until we hit something that's not an A or a Z, which is probably a space or a new line. Go down here. Else, if the character is in, let's see, space, comma, space, period, comma, exclamation mark, or question mark, which we saw earlier, right? So basically, if we've hit the end of something that you would expect to find after a word, we say, hey, is Z word equals to 1? In other words, did we find a word that contains a Z? If we did, we were going to print current word, which is, remember, where we were building up our current word. We're going to set current word to nothing, so we reset, and we're going to set is a Z word back to 0. This is, okay, great. So we're all back to 0 on that. Now, if it's not, let's see, if it's not a Z word, then we're just going to wipe out current word, throw it away. This is the, or and, or something like that. We don't care about that. And we're going to keep on, the character equals the next letter. Keep doing this, keep doing this, keep doing this, and then we're going to close the file. No rocket science here, right? Just a little bit of smarts as to when a word starts and when a word ends, and we just build up this little variable that holds the current word, and we discover that there's a Z in the current word. We're going to say, great, let's go ahead and print that word out. How many Z words are we expecting?
17.
Would you like to guess at what the Z words are?
Lazy.
Lazy might be in there. That would work.
Probably some mad people.
All right, perhaps for the first time ever, anywhere, shall we discover what words that contain Z are currently in the U.S. Constitution?
Citizens.
Oh, of course.
Lazy isn't even in here.
Authorized.
So we got
What's the
some
last one?
authorized naturalization organization. So these are all, once you see them, you're okay with that. This has got to be somebody's name. Fitzsimmons Gerard. So that individual must have signed it somewhere towards. Okay, also remember, it is actually it is the last one on the list,
It's
right?
probably Jared Fitzsimmons.
I'm gonna look it up.
It's interesting to say magazines, but I bet they're talking about like guns.
Yeah.
I
Yeah.
Yeah, there's definitely this
during
space.
Is there what's
All of them.
Say erasure. I didn't have.
Right.
We still had like English.
I couldn't figure out what it was. That was like erratic.
Yeah, Jared is the first name.
Is there no space in the U.S. Constitution on that one?
Well, you were close with Benjamin Franklin and so.
So there you go. You learn something new every day, including Z's in the U.S. Constitution. Go figure. All right, something else that you may end up doing at some particular point in time is reading in records. So what is a record? A record is a collection of data items in a data file that are all related together. In all honesty, back then doesn't really have anything special to deal with this, so the responsibility for grabbing the entire record comes down to you and your programming skills. A text file can contain a collection of data records in which each record consists, and here comes the key, multiple fields. Like patient data, right? Last name, first name, middle initial, whether or not they have insurance, what their social security number is, what their date of birth is. So file, another example, of course, would be student data, which consists of records, consists of ID number, full name, address, and class year. A file containing a bank account, obviously has a bunch of stuff having to do with the bank account. When you're working with text files that contain data records, you generally have to read the entire record before you can process it. And that makes perfect sense, doesn't it? So for each record in the file, read the entire record, and then of course go ahead and process it. So this is one of the tricks where you don't want to read in characters, you don't really want to read in words. You want to keep reading until you have, for example, the complete patient data record. Okay, the organizational format of records can vary, of course. However, making some formats easier to read than others. How to build a record by reading multiple lines from a file. The first file, the first record has to be obtained as a priming read. So in other words, you read it in the very first thing just to make sure that you're actually in the right place in the file. Okay? Always a possibility. Either the file's empty or there's just nothing in that particular part of the file that has what you're looking for. Once you're inside your loop, that should be sucking in all the individual fields for the records that you're trying to build. The remaining fields of the record have to be read from the file. So basically, if I was reading in, for example, a patient's medical record, I know that there's, I think, 10 items in a patient medical record. So once I got the first one and confirmed that I'd gotten the last name, I want to go ahead and read the other 9 items because I know that they make up a complete record for that person. The one thing you don't want to have is like you're missing something all the time. Okay, the new line character is stripped from the end of string fields, and the strings containing the numerical fields are converted to their appropriate type. So remember, when it comes in from the file, it's sort of messed up, right? Everything's going to have that new line character on it, and everything's going to be a string, even if it's, for example, like a social security number or a date of birth. At the end of the loop body, after you've read everything in, the first file of the next record is obtained as a modification read. So you keep, at the end, after you've read it in a record, you're all good with it, you process it, you put it on the right places and stuff like that. You want to do another read to see if there's any more data records that you have to grab. So data records aren't that hard to do, but as a programmer, you have to understand that just one piece of data that you read in isn't enough, because it's really a data record. So you have to make sure you grab everything that goes into the data record and be able to work with that. Okay, brand new topic here, exception handling. So when you write your Python code, you've probably written code and had it bomb out on you. You've actually had your program come up to a screeching halt, and you've had little red lines of code appear on your screen that said, you did something really, really bad. Okay? As you move into the brave new world of using files, there's a possibility that's going to happen a lot more frequently. Specifically, like if you say to a customer, hey, go ahead and enter the file name that contains the data, and they've got fat fingers, and they mistype the file name, you go ahead and you'll try to open that file, it doesn't exist, and Python's going to go belly up on you. Say, listen, I can't find that file, I'm coming to a crash and halt. You don't want your programs to do that. You don't really ever want your program to crash, right? So Python has a technique they call exception handling that can help you deal with this. Except 2 aspects to dealing with program errors, detection and handling. So did something bad happen? Yes or no? And if it did, what should I do about it? Are the 2 questions you're trying to answer, okay? The open function can detect an attempt to read from a non-existent file. However, it can't handle that error, right? The program dies. The program's not there, I'm crunching. A much better way of handling this would be to terminate the program or at least ask the user for another file name. Okay, I think you mistyped the file name, you want to try again. Yes, I do. Okay? But here's the problem. Opening a file, like we've seen, okay, can't handle that. Okay? It doesn't know how to choose between the alternatives. It has to report the error to a brand new part of the program. Okay? Okay, in Python we use what's called exception handling to be able to handle errors when they pop up on us. Python has a whole bunch of different exceptions. So exceptions at the top of the tree, we've got warnings and standard errors. In standard errors, we've got environment errors. I/O error is a very classic environment error. Basically, it means you're trying to do something wrong with the file. Arithmetic error, we've got overflows when things got too big, or 0 division error. You can never, ever divide by 0. You do, bad things happen. Runtime error, type error, value error, lookup error, index error, and key error. This is when we're dealing with other types of data structures, right? These are all the common errors that you can have exceptions. Things that cause your program to crash would be a good way to refer to them to the chart. Okay? So let's see, let's talk about if you're creating a banking account program. When you detect an error condition, your job's actually really easy. You just raise an appropriate exception and you're done. Right? If they try to do something they shouldn't be able to do, you flag it as an exception and you move on. So for example, if you try to withdraw too much money from your bank account, if the amount is greater than the balance, what should you do? You really shouldn't let them do that, all right? So the very first thing we have to do is figure out, well, what kind of exception do we want to raise? So if we go back here and sort of look around at what we've got on here, there's an interesting question, arithmetic error, because we're trying to take too much out of an account, is a natural possibility we might want to consider. But I'm not sure if it's really correct, and the answer is probably no. Okay, because we can handle negative numbers, that's not a big deal whatsoever. Is the amount should be thrown an illegal value? No, it's not just, it's too large, right? You don't have that kind of money. So, probably value error. Where's value error? Oh, here we go. Value error would be a good type of exception to raise in our bank account program. All right, so here's how it goes. If amount is greater than balance, then we say raise value error, and we send the string, amount exceeds balance, right? Basically, if you want to use fancy computer talk, this is the go-to statement, okay? It says, stop. You're trying to do something that's illegal. I will not process any additional Python code. I'm going to send you off to a brand new part of the program, almost like a function call. But it's a function call with no return. Okay? I'm actually transferring control to that part of the program, and you can go run whatever's there, because it's going to handle this particular error. When you raise an exception, the execution does not continue with the next statement. There is a statement here you'll never get to, okay? But it goes on and transfers this part to another part of the program, that is your exception handler. So raise exception, okay, if amount greater balance, raise exception, and we will never get to the next line of code because the exception was raised. Okay, handling exceptions. Every exception should be handled somewhere in your program, otherwise you got problems. If the exception has no handler, an error message is printed and your program crashes. Of course, doing that will make your user very sad. Okay? You handle exceptions with what's called a try or except statement. Okay? Place the statement into the location of your program that knows how to handle a particular exception. So what's going on is you identify parts of your code that are dangerous code. For example, opening the file. You know that's dangerous code. You know that bad things can happen when you try to open a file. If the file's not there, your program's going to crash. So you identify that section of code as being, whoa, danger code. That's your try section. Okay? If anything bad happens during the try, you then have exception statements that will handle the bad things that can happen. Right? Okay? Try block contains one or more statements that may cause an exception. Each except clause contains a handler for an exception type. So here's a good example. So try in file equals open, line in file read line, and process line. So really just 3 lines of text here. We know that we can crash out almost on any of these, okay? So if in file has a problem, we have an except statement here, IO error. Remember, that's the one that gets raised if you have problems opening a file. And you could not open input file. Cool, so that's it. That's all that gets printed. Now if you have any other problems with what you actually read in, we can accept exception as exception object. We can say error, and then we print out the string which was automatically generated that explained what the problem was. So here we have 3 dangerous lines of code, and we have 2 exceptions that can handle pretty much anything that's going to happen there. Something with the file, or actually something with the data that was read in. The finally clause. So all of this try, exception, and handling errors leaves us in a little bit of a messy situation. Here's the case in point. So we have a file that we've opened up. We were doing some stuff with the file, and bad things happened. And so we ran off, went to special code, and handled the situation, and did all that sort of stuff like that. That's fine, but this file is still open. So finally is designed to allow us to basically wrap things up. We can close files, we can clear out variables, we can dispose of things. Finally, it always gets executed. So it gets executed. If I make it through my try code with no problems, if there's no errors, I'll go down, I'll execute finally, and I'm out of there. If I go through my try code and there is an exception, something bad does happen, I'll run off and take care of the bad thing, but after I'm done with the bad thing, I'm going to come to finally, and I will execute this code also. So the out file in this case will always get closed, no matter whether there's a problem or not a problem. Here's a good example. So here's the code. Out file equals open, out file, filing for writing. Write data to the out file.close. Real simple stuff. No big deal whatsoever. But because that there can be problems with this, I'm going to rewrite it to basically handle any potential problem. Out file equals open file name W. Try. Write the data. So I'm actually going to try and send it out. If there's a problem with that, I'd run off and handle it as an exception. Here's my finally statement. So here's my out file.close. No matter what happens, whether there's a problem or not, I'm actually going to end up closing that file. So I will wrap things up. In normal cases, there's going to be no problem. When the front block is completed, finally clause will be executed. Fantastic. When there is a problem, we'll go handle it, but then we'll still execute the final block. Okay? And we basically use it for cleanup. So what's in your Python toolbox now? Well, good news, we've added, well, we had files, but now we've actually added exceptions to it. So you got one more tool. Not bad. That toolbox is pretty cool. So what did we cover today? We talked about reading lines from a file. We already had a way to do it, but we came up with another way to do the same thing. We said lines is good, but sometimes we want to actually read words, individual words from a file. Turns out that Python gives us the ability to do that. Then we went on and said, hey, how about screw words? Let's go ahead and read individual characters out of the file. Good news, we can do that. If it turns out that we want to read like a customer record or something like that, we can read records from a file. We just have to be smart enough that we're actually reading records. And once we get one part of the record, we have to go on and read the whole record. And then we have to make sure or check to see if there's any more records in the file to be read. And we wrap everything up today talking about exceptions and how you handle tricky situations where bad things can happen. Well, that is great. Whatever shall we talk about next time? Sets. Ooh, brand new data structure next time. Wow, exciting. But you know, we'll put that off until next week. You can get homework over. Have a great weekend, guys. Enjoy.